Hello everyone, I am Suli Yao, a PhD graduate student from the Chinese University of Hong Kong, and it's my great honor to have the chance to share with you about my recent work focusing on the seismic hazard assessment and ground motion predictions based on the interseismic locking models. The ground motion prediction is a very critical element in seismic hazard assessment, and it is usually conducted by using the ground motion prediction equations that derive from the ground motion records, which describe how the ground motion intensity decay with the epicenter distance. However, such methods usually suffer from the lack of the near-field data. To fill in this gap, we can use other methods such as the dynamic rupture simulations to simulate the ground motions in the near-field region. And such dynamic rupture simulations are well known to highly depend on the model inputs, such as the fault geometry, the velocity structure, and also the initial stress on the fault. However, due to the lack of the direct measurements for the stress on the fault, the initial stress is usually assumed to be uniform or depth-dependent or stochastic in dynamic models. Here in our study, we intend to use the interseismic locking models as the constraint on the fault stress. The locking models reveal the distribution of the slip deficit accumulation on the fault during the interseismic periods, and those highly locked regions are anticipated to have significant co-seismic slip in future earthquakes, and thus may feature high earthquake potential. Our study region is the Mid-America subduction zone in Nicoya, where the Cocos Plate subducts beneath the Caribbean Plate, and there is a very dense geodetic and seismic observation network installed on the Nicoya Peninsula. Based on those observations, there have been two locking models for this megathrust, and in this map view, we can see the well consistency between the two locking models with some slight differences in details. And in 2012, there is a magnitude 7.6 earthquake occurred on this megathrust. And we can see a very large overlap between the co-seismic slip and the locking models. So the extensive near-field observations in this region actually offer us a very good opportunity to investigate the link between the interseismic locking and the co-seismic rupture. So what we want to do is that we derive the rupture scenarios and the ground motion predictions based on the locking models in this region. And then we validate our predictions by comparing with the 2012 events. And then we can investigate the feasibility of applying the locking models in seismic hazard assessment. So the first step that we take is to estimate the initial stress from the locking model. And then the initial stress is used as the input for the dynamic rupture simulations. And here I show you a case. We nucleate the rupture from the hypocenter of the 2012 event here, and then we conduct spontaneous rupture simulation and get this scenario. We find that the final rupture extent and the moment magnitude and also the moment rate function in this scenario are very similar to the 2012 event, which indicate the potential of predicting future earthquake from the locking model. However, one question is that we actually do not know the location of the hypocenter for future earthquake before its occurrence. And based on our simulations, we find that even with the same initial stress distribution, the different hypocenter locations may lead to totally different rupture scenarios. For example, if the earthquake initiates from the blue star here, and finally it will grow into a breakaway rupture with a final moment magnitude of 7.4. However, if the earthquake starts from the a red star just neighboring to the blue one, it will only result in a 5.7 event, confined in a very small region, and which we term as the self-arresting case. We test a sort of different nucleation size in the locked region as indicated by those small circles, and the color for each circle indicate the final moment magnitude for each scenario. We find that the earthquake that nucleated from the highly locked region will have higher potential to grow into large earthquakes. And among those scenarios that we derived from the Feng's locking model, 29 of them finally turn into breakaway cases and eventually break the whole locked region with final moment magnitude around 7.5. And those colored curves in each panel indicate the final rupture extent in those scenarios. We found that despite some very slight differences on the offshore patch, actually those scenarios are well confined in the highly locked region. Those blue triangles indicate the locations of the local high-rate GPS and strong motion stations that are used in the prediction validation later. Even though with very similar rupture extent and the moment magnitude, different hypocenters may lead to different rupture process and thus may impact the ground motion intensity. So here we compare the ground motion, the synthetic ground motion on this station in the 4 scenarios with different hypocenters. And then we find that the scenario that nucleate away from the station and propagate towards it finally result in the strongest ground motion intensity on this station, the scenario in the panel A, just because of the rupture directivity towards the station. And then we generate the predictions for the ground motion intensities, including the peak ground velocity, acceleration, and displacement among all the breakaway scenarios. Because here we only want to capture the high-risk ground motion in this region, so we only consider those breakaway cases. And since we do not know about the future hypocenter, so we treat each model equally in the calculation. And here, the blue and the black dots and the arrow bar shows the predictions and the standard deviations on each station. And the blue stars are the observations during the 2012 events. We can see that actually most of the individual measurements are captured by our prediction within 1 standard deviation. And the light blue and the gray lines indicate the average value among all the stations in the observation and our prediction. And we can also see that the great consistency between the 2 values. Please note that we have applied low-pass band filters on the waveforms before we picking the PGV and PGA. We also compare the predictions and observations in the spectrum domain and find the great consistency in the frequency band from 0.02 Hz to 0.5 Hz. For the higher frequency, because here we apply a very simple layered velocity model and the lack of the heterogeneities in smaller scales for the structure. So the higher frequency energy, like over 0.5 Hz in our ground motion predictions, is inadequate. That is why we have to apply a low pass band filter on the waveforms before we picking the PGV and the PGA. And the story is a little bit different in another locking model. So based on Xue's locking model, we only have seven scenarios that finally rupture the whole locked patch. And instead, we have some other scenarios that confined on the offshore patch or only confined on the onshore patch and terminate at the gap between. That is because there is a gap with very low locking degree between the offshore and the onshore patch, which may impede the rupture propagation and forming such rupture segmentation phenomenon. And due to the less energy release, those magnitude 7.2 events predict the intensity is lower than the magnitude 7.5 events by around 30 to 40%. Okay, so in summary, we derived the rupture scenarios and the ground motion predictions based on the interseismic locking models in Nicoya by considering different hypocenter locations. And then we compare our predictions with the observations during the 2012 events and find that our prediction can fit the observations in the low frequencies. And furthermore, we observed the rupture segmentation in rupture scenario that derive from stress locking model. So such observations may indicate the high dependency of our predictions on the locking model resolution and highlight the potential challenge in predicting the future earthquake magnitudes and the ground motions. And that's all my presentation. Thank you for listening.